Okay, so this is the worked out answers for the quiz version B that you had on Wednesday. And I'm just going to go through each, try to explain each step so that hopefully that'll help you out as you do your redemption this weekend. So first thing is on the very first problem, I didn't want you to do it with the chain rule if you knew it. I wanted you to do it by definition. And what that means is you needed to apply the limit as h went to 0 on the function evaluated at x plus h minus the function evaluated at x all over h. And so for this particular function, that meant you were taking the square root not of 2x plus 2, but of 2x plus h plus 2. That's the function evaluated at x plus h, minus the function evaluated at x, which is what I gave you, all over h. So you needed to have a strategy for how you're going to take this limit. If you tried to just plug 0 in, you get 0 over 0. So for this limit, the strategy was to use the conjugate. And in this case, the conjugate is the same two radicals that you have up top, but with a plus sign in between instead of minus. So you wanted to write this 2x plus h plus 2, 2x plus 2, and in this one again, 2x plus h plus 2, and 2x plus 2. What happens when you multiply by the conjugate is you FOIL the top, but when you multiply the firsts, because they are the same radical, you end up getting the radicand as your result, because a radical times itself gives you the radicand. So that would have been 2x plus h plus 2. And when you multiply the lasts, same thing happens with a minus in between. So I'm going to use parentheses so that I subtract the entire quantity. And the outer and the inner terms are not freed from the radical, but they're opposites of each other. So they add to 0. So I'm not going to even write them down. I don't need them. I know they go to 0. That's why I use the conjugate. In the denominator then, you'll have h, which was down there, times the conjugate, which you multiplied on top and bottom. When you distribute your negative, what's going to happen is the 2x from here and the 2h from here are going to have, you're going to have an opposite from the 2x, but not an opposite from the 2h. So this is 2x, but this is minus 2x. This is 2h, and then I have a plus 2, and I'll have a minus 2. So the only thing left in the numerator when I distribute and I subtract is 2h. And that's good news, because then that will divide out the h that I have on the bottom. And once it divides away, I can take the limit, which sends the h that's remaining to 0, and I'll end up with a 2 on the top and a radical 2x plus 2 plus another radical 2x plus 2 on the bottom. Some people inadvertently added them together by squaring them. That's not how you add them. You add them by getting 2 of them. So 2 radical 2x plus 2, and then to finally simplify, you can divide away the 2's, and this is your derivative by definition. So that was the longest problem on the quiz. Number 2, when you had to find and simplify the following derivative, the derivatives of the following functions, now I'm not asking you to do it by definition. So for this one, I could think if I FOIL it out, so I'm rewriting my f of x. I'm not jumping into a derivative. By FOILing it, so I'm multiplying it by itself, I'm going to end up with x to the 4th minus, by itself would be x squared minus 2, 4x squared when I do my outer and my inner and add them, plus 4. And now that it's all FOILed out, I can take the derivative with the power rule. So that will leave me with 4x cubed, because the 4 comes down to be my coefficient, and I subtract 1 from my exponent, minus 8x, and the derivative of 4 is 0. For B, some people forgot that yes, you need the quotient rule, because this is a binomial, but I said that sometimes if you can simplify your fraction before you start, it'll make the process a lot easier. So because the denominator factors into t plus 1 and t minus 1, and the numerator factors into t minus 5 and t plus 1, if you divide out the t plus 1, then as long as t stays away from the value negative 1, you could take the derivative of the simpler fraction, which means it's going to have a simpler derivative. If you didn't do that, no one was successful in simplifying it all the way down to its simplest version. But I only took a half a point off if you did it the other way and you didn't simplify it. But now I'll do the quotient rule on the simpler fraction by squaring the denominator, starting with the denominator, taking the derivative of the numerator, minus the numerator times the derivative of the denominator. And since the derivative of t minus 5 and t minus 1 are both 1, it comes out very simply. T minus t is 0, and negative 1 minus negative 5 is going to simplify to the number 4. So that's the simplest version of the derivative there. For C, my function looks like a fraction, so it looks like I need the quotient rule, but you don't need the quotient rule. And remember what we said, if the denominator is a monomial, then I can use the power rule. And that's always going to be faster and easier to simplify. So I'm going to rewrite. So far I've rewritten every one of my functions, and even I'm going to do that on D as well. So I'm going to rewrite it as 6x to the 4th over 3x to the 1/2 minus 2x over 3x to the 1/2. And then I can rewrite it again. 6 divided by 3 will give me a coefficient of 2. X to the 4th divided by x to the 1/2, that's when I subtract my exponents. So 8/2 minus 1/2 is 7/2. Haven't taken the derivative, I'm just rewriting this. And I'm going to rewrite this fraction as well. 2 divided by 3 is going to have to remain 2 divided by 3. 1 minus 1/2 means the exponent here is 1/2. So this rewrite we just did is just like you did on the extra credit assignment in class, and it is going to be something you want to get very comfortable with in this chapter to save yourself time. But now I do have to take the derivative with the power rule, so I'm going to multiply 7/2 by 2 and get 7, and subtract 1 from 7/2 to get 5/2. Then I'm going to multiply 1/2 times 2/3 to get 1/3, and take away 1 from 1/2 and get negative 1/2. Then the only thing you have to do to finish it off is move that square root of x, or the x to the 1/2, whichever way you want to think about it, to the denominator of that second fraction. And there is my derivative. So notice I didn't give you much space, and that's an indication that if you went with the quotient rule, you probably were doing something you didn't need to do. For D, same idea. You want to rewrite it. You want to figure out what's the coefficient and what's the power on x before you start to try to take a derivative, because the quotient rule is very unnecessary here. If you do the quotient rule, part of it's going to end up being 0, because when you take the derivative of 5, it's 0. So definitely don't want to do the quotient rule here. I know that the coefficient is 5/2. Now, a lot of people took that 8 from out of that cube root and thought it was still an 8. You cannot remove an 8 from a cube root unless you call it the number 2. So that's why the coefficient was 5/2. The exponent on x in your original problem is negative because it's in the denominator, 1/3 because it's under a cube root. So once that's rewritten, now I just need the power rule. And to take the derivative, I'm just going to multiply negative 1/3 times 5/2. And then I'm going to subtract 1 from negative 1/3, and that's negative 4/3. So my final answer for the derivative is negative 5 on top with a 6 on the bottom, and the x to the 4/3 will go down there as well. So that's the answer to 2D. So moving on to the second page, we had find the equation of the tangent line. So if you look at your review sheet, this is something I said you'd need to be able to do. The steps were to take the derivative, because the derivative is going to get you the slope of the tangent line. Then after I find the derivative, I'm going to plug in the number 9 from my point here, and that'll give me the slope that I want for the line that I'm trying to write the equation of. And then after that, I'm going to put it into slope-intercept form. So I'm trying to figure out this slope. So this particular function, again, requires a rewrite. There's a theme here. You don't look at it as I gave it to you. You look at it to figure out what the coefficient is and what the exponent on x is. If otherwise, you're going to have to do the product rule, which some people did successfully, but it's faster if you add these exponents together and think about this as 2x to the 5/2, because it's easier to take that derivative with the power rule. It's going to be 5/2 times 2, which is 5. X to the, take 1 away from 5/2, it's 3/2. So then you're going to plug the number 9 into it to get your slope, because f prime of 9 means the slope of the tangent line when x is 9. And that's going to be 5 times 9 to the 3/2, which is 5 times 3 cubed, which is 5 times 27, which is 135. Then all you needed to do was stick 135 in there and you were done. The slope of the tangent line is 135 at the point 9, 486. Number 4, I asked you to write a demand function. Remember, a demand function connects x and p, where x is the number of tickets sold and p is the price of those tickets. And so the information I gave you allowed you to come up with an x value of 34,000 matching with a price of 8, and an x value of 24,000 matching with a price of 12, which should lead you to a slope when you subtract and subtract, put your y's on top and your x's on the bottom, and you end up with negative 4 over 10,000, which reduces to negative 1 over 2,500. Now you can write your equation, because I said assume it's linear. So y minus a y value should equal this slope times x minus the matching x value. And that leads you to y minus 8 equals negative 1 over 2,500x plus 34,000 divided by 2,500, which I need to check because I don't remember offhand what that was. So 34,000 divided by 2,500 is 13.6. And then I can add 8 to both sides and turn my y into a p, because that's what the y value was standing for. If you remember, we always put the money here, which was the price, and the units here, which was the tickets. That's my x value. So my price equals -1 over 2,500 x plus, when I add 8 to both sides, 21.6. So there's my demand function. We've done that several times. On the review sheet, I also said if I give you a demand function, you need to know how to write the profit function. Well, that required that you first get the revenue function. And revenue is always x times p. And in this case, here is my p. It's right there. It's not a number because the price is going to change depending on how many tickets I want to sell. But it's a function. So I'm going to take x times the function that is my demand function and get -1 over 2,500 x squared plus 21.6x. So that's my revenue function. Profit is revenue minus cost. So to figure out cost, I've got to go back to the equation where I said what the fixed and the variable cost were. Fixed cost was 20 cents a ticket, and 85,000 was the, variable cost was 20 cents a ticket, and the fixed cost was 85,000. So I'm going to take my revenue function and I'm going to subtract 0.2x for the variable cost, and I'm going to subtract the fixed cost of 85,000. And the best thing to do with that would be to combine like terms, although I didn't take off if you didn't. But final answer for the profit function looks like that. So you're going from demand to revenue by multiplying by x, subtracting cost from revenue, and that gives you profit. So after we got the profit function, the C question said calculate P prime of 20,000. Well, if P is -1 over 2,500 x squared plus 21.4x minus 85,000, P prime is -1 over 1,250, which is 2 times this coefficient. Change the degree from 2 to 1, and then the derivative of 21.4x is just 21.4, and the derivative of this is 0. So now I'm going to plug 20,000 into my derivative and calculate P prime of 20,000. So I need to take 20,000 divided by -1250, and then I have to add on 21.4, and I get 5.4. And so that leads me to the P prime of 20,000 that I want, and now I'm supposed to describe its meaning. So what I wanted to see with there was if you knew that you just found marginal cost, marginal profit. But the easiest way to describe it is you just hopped off of your profit function onto the tangent line, and you figured out what you expect the profit to be for the next unit you sell. And that's the 20,001st unit. So that's the easiest way to answer that question. What I expect to get for the next unit I sell or the next ticket I sell. And since it's positive, that would mean I probably should try to sell that ticket. If it was a negative marginal profit, then I wouldn't want to be selling anymore. Okay, so that's the definition of marginal. And then finally, I gave you a question on the quotient rule in general. So if you look at your review sheet, I think I had one of these problems on the product rule in general. But the best thing to do for this problem was to say, if I'm trying to find h prime of anything, I'm going to write down how I take the derivative of this. Since it's a quotient, I'm going to square the denominator, start with the denominator, multiply it by the derivative of the numerator, minus the numerator times the derivative of the denominator. That's the quotient rule in general. So now to find the derivative at the value of 2, I need g of 2, which I know, it's right here, it's -3, times f prime of 2, which I know, it's 5, minus f of 2, which is -4, times g prime of 2, which is 3, all over g of 2 squared, which is -3 squared. So when I plug in everything I know, I get -15 minus -12 all over 9, which is -3 over 9, which is -1/3. And then I'm finished. So hopefully this working out will help you when you go and print out the redemption for this quiz and work on it this weekend, and you hand it in at the beginning of class Monday for some extra credit.